Our fourth example, illustrating how U substitution is used to evaluate somewhat complicated integrals, we are asked to evaluate the integral of minus the cosine squared of x times the sine of x dx. So we're going to let U equal cosine of x. And you'll notice up here I did a little rewriting. So I have cosine squared of x, and I moved this minus back here with the sign. So I have minus sine of x dx. And the reason why I chose U to represent cosine of x is because that's the expression raised to the power. When trying to decide which one of the functions to be represented by U, it's often a good idea to choose the one that's raised to a power. Next, we find the differential. We find du. So u is equal to the cosine of x. Du is equal to minus the sine of dx. And if you look up here, we have that same exact expression, minus the sine of dx. This is going to get replaced with du. Rewrite the integral in terms of u to make the integration easier. So we said that we were going to replace minus sine x dx with du. We already said we were going to replace cosine with u. That's how we get the integral of u squared du, which is a fairly easy basic integral for us to evaluate. The integral of u squared du is equal to 1/3 u cubed plus c. You know that by doing the opposite of differentiation, adding 1 to the exponent and then dividing by n plus 1. Now that we have our integral, we can go back and replace u with its original value, cosine x. So we have 1/3 cosine x. This u was to the third power plus c. Now, as an extra check, you may want to pause the video and see if you can differentiate this. And if you do, and differentiate this correctly, you should get the original function found up here in the integral. Or I should say it this way. Differentiate this and see if you get the original integral that you started with.